Here is a challenge. Give me a few minutes and I will turn a math concept on differential equation of order 1 that looks scary into something you can solve with confidence. Let me show you how to solve them step by step and actually enjoy it. Example, are given this kind of equation and asked to determine if the equation is homogeneous and to solve it. First, we should know that an equation is homogeneous if its first derivative of dy over dx can be expressed as a function of v only. Example, on this equation, we're going to let y is equal to vx. This general equation is going to be dy over dx, where there is a value of y going to replace with vx, which will give you v squared minus x squared over 2x vx. If you open the bracket, it's going to give you v squared x squared minus x squared over 2 x squared v. Next step, we are going to factorize, which will be x squared into v squared minus 1 over x squared 2v. X squared going to cancel with x squared. We are going to remain with v squared minus 1 over 2v, which is the function of v. This equation is homogeneous because we are from the original equation we are expressing it in terms of v only. Therefore, we can say that this equation is the equation is homogeneous because we already expressed the function in v form. So next step, let's solve the equation. To solve the equation, we're going to already say that y is equal to vx. We're going to find the first derivative, which will be dy over dx is equal to, because it's v multiplied by x, we're going to use product rule, which will give you v plus x dv over dx. From here, we're going to compare this equation with the homogeneous equation in terms of v, which will give you v plus x dv over dx is equal to v squared minus 1 over 2v. After writing the equation, next step we are going to collect like term, which will be x dv over dx v squared minus 1 over 2v. V, if it move on the other side, is going to be negative v. Then we find the LCM of this function is going to be 2v, which will give you v squared minus 1. You subtract 2v multiplied by v is going to be 2v squared. This is going to give you v squared minus 2v squared is going to be negative v squared minus 1 over 2v. After writing this equation, the next step we are going to factor out the negative sign, which will be negative v plus negative v squared plus 1 over 2v. The next step, we are going to separate this variable of v and x. To separate this value, we are going to find the reciprocal of this function, which will give you 2v over v squared plus 1, and we write dv is equal to, again we are going to do the derivative of x over dx, which will be dx over x, and the negative sign will remain on this side. After writing this equation, next step we are going to integrate both sides. This equation, to integrate this equation, we are going to use integration by substitution. So we are going to let t is equal to v squared plus 1. dt is going to give you 2v dv. Therefore, integration of 2v over v squared plus 1 dv is the same as, where there's value of 2v dv, we are going to replace with dt. So it's going to give you dt, and where there's value of v squared plus 1, we're going to replace with t. So over t. This is going to give you ln t. And you recall that t is the same as v squared plus 1. So this will give you ln v squared plus 1. And the integration of negative dx over x is the same as ln of the integration of negative dx over x is the same as ln of x. Then we can write this equation in good form, which will be ln vx squared plus 1 is equal to ln x plus c. But this will give you, it will be negative because of negative sign. After writing this equation, you should recall that v is the same as y over x. So this equation is going to be ln y squared over x squared plus 1 is equal to L and x plus c, negative. After writing that, we can say, if you find out the LCM is x squared, so it's going to be x squared plus x squared over x squared. If this one, ln of x, move on the left hand side, is going to give you positive ln x, which is equal to c. And this will be the solution for this equation. Thank you for watching my video.